Class, what's up? Welcome to another video. Today we continue practicing our log rules and solving, and then we will introduce a concept that will help us get ready to graph, because we're going to start graphing logarithms, or logarithmic functions I should say, next week. So that's really what this video is, solving, a little bit of introduction, and then after the video, which I hope is a decent length of decent length of time, you guys, I'm going to have you try some of your own stuff at the end, okay? So, let's jump right into it, and let's remember our log rules. Alright. Rule 1, log base A of 1 equals blank. Remember, if you use your log circle, you're trying to figure out what exponent you need to raise A to get 1. And we know that to get 1, you need to raise anything to the power of 0. Alright? What if we move on to this one? Same idea, same concept. We need to raise this base of A to some power to get this A. Well, A to the what power is equal to A? Easy. 1. How about this next one? We have a base of A, argument A to the rth power. What do we have to raise A to equal A to the r power? Well, you have to raise A to r. Alright? And the last one, probably the funkiest of them all. Remember that this is currently in exponential form. You could write it in log form if you would like. If I do that, it would be log base A of blank equals log base A of m. And so we know then that our blank has to be the letter m. Ideally, guys, you're just going to start learning these and just recognize when you have base being raised to a log with the same base, they're just going to kind of cancel each other out. Alright? So yes, that should be the letter m. Let's move on. We know that when we have an argument that has two pieces being multiplied together, we can always split. We can always split using addition, okay? It's kind of the opposite. Remember, we've talked about this. It's kind of the opposite of exponents, all right? Exponents, you have to see addition, or sorry, you have to see multiplication to add. I don't want to confuse you. Never mind. Together, these are multiplied, which means they split using addition. Exponents are completely opposite. Or when they're apart, they're multiplied, and so when you put them together, you have to add. When we have division inside the argument, it works very much the same. However, we need to subtract the logs to separate. Okay? We separate the logs using subtraction. Our next rule over here, we remember that when we have a power with a log, we can always bring it out front. So this would be r log am. Alright? Please make sure you understand that this r is being, or is the power of the argument, okay? It's not this. Alright, this is no good. If you saw this, these are not the same things. You have to understand that this r is actually the exponent of m. Alright? And lastly, probably my favorite, just because it makes problems super simple, is if we know we have logs with the same base set equal to each other, well then the arguments must be equal. Alright? So, we're going to do some solving. And yes, let's take a look at this first problem. Now, I see two logarithms on opposite sides of an equal sign, which means I'm probably going to want to use something like this. However, we cannot do this yet. If you notice, are there any coefficients on these logarithms? There are not, okay? So we cannot do anything with this yet, but we do know, what can we do with this too? Yes, we can bring it back into the exponent of the argument, which means I now have two logarithms with base of 5, which means I can set my arguments equal to each other. All right. Notice we're squaring, which means we have to do the inverse operation, which would be square root, so x equals plus or minus 3. Now please be very careful, check for extraneous solutions. I have a log base 5 of x. Well, when I plug in -3, that's going to make my argument negative, so I do not have both of my solutions. The -3 is extraneous, which means I need to write x equals 3 and box it on its own. Okay, if we move on to the next one, I see two logarithms on the same side. I see just a number over on the right side. This looks like one where I'm going to want to just create one single logarithm and then maybe use the log circle to help me solve. So I'm going to go ahead and I'm going to do that. I see two different logs separated by addition, so I know that I can multiply the arguments together. So let's do that. X times x is x squared. X times 2 is positive 2. 6 times x is positive 6, so plus 8x. And lastly, 6 times 2 is 12. Alright, so now I have a logarithm. I can just use my log circle, okay guys? 5 to the first equals x squared plus 8x plus 12. 0 equals x squared plus 8x plus 7. Ooh, and this is factorable, perfect. What do we got here? X and x. How do we get to 8 from the factors of 7? Well, we just got to add 7 and add 1. So now we know our solutions should be -1, -7. Let's make sure they both work. Plug in -1. Good, good. Okay, -1's good. -7? Ooh, no good. See ya. X equals -1. Alright, why was -7 no good? Because when I plugged it in, here or here, doesn't matter, it gave me a negative argument. And we know that arguments of logarithms must be positive. Okay? Good. Last example on this page, I see a bunch of logs. I would say, if I see logs on both sides, one nice way to kind of think about this would be right here. Okay? Now you need to be careful that we've seen situations where you need to move this over to the other side, and you can move this over to the other side right now if you wanted to and just kind of create one big logarithm. Sorry, one big natural log. But I don't know. I think that's harder. I'm thinking if I can get these two into one, well then I'll have a log equal to a log, and I can use that rule that we talked about earlier. Okay, so let's try it. Let's see if we can get there. Alright, ln x minus 4. Okay, so same base, addition, that means I do what with the arguments? I multiply them. So x squared minus 4x equals ln x plus 6. And now what can I do? Because I have two logarithms, same base, equal to each other, I just take the arguments and set them equal. When I move everything over to one side, because this is a quadratic, and I have to solve this quadratic by setting it equal to 0, I get x squared minus 5x minus 6 equals 0, which means when I factor, I should get x and x. Let's go back 6 plus 1. Yes, that's how I get to -5. Perfect. So now I have -1 and positive 6 as my options. What do we have to do? Of course, we need to check for extraneous solutions. What do we notice? When we plug in -1, well, we're good here, but not here or not here. And it just, as soon as it doesn't work once, you know it's extraneous. So -1 is no good. 6, okay, 6 is fine, so my final solution would be x equals 6. Alright? Okay. Now, I know we've done a lot of work with just logs. I do not want you to forget how to work with exponents. All right? Just like let's flip back for a second. Just like when we have a logarithm and our x is stuck in the argument, we need to try to get it into exponential form, which is what we did there. Well, we need to do the same thing, but kind of opposite, when we have exponential form, sorry. All right, 2 to the x equals 5. My x, my variable, it's stuck in the exponent. So I want to switch to logarithmic form, which means I know the log base 2 raised to the xth power will equal 5. And guys, that's all I need you to say. If I want you to solve, I need x alone, x is alone, I am good right there. If you wanted to, you could plug this into your calculator, or you'd have to use change of base, but you can get me a value. But I'd rather have an exact answer. Okay, so this is good right here. Now in this next example, it's very similar. However, just like on the page before, and you can't really use any of our log rules or exponent rules until it's just a single logarithm, it's the same thing with exponentials. I have an 8 out in front here. I can't do anything with this side yet. So what I need to do is I need to use any algebra I possibly can to get this exponent piece alone. So hopefully you agree that if we divide both sides by 8, well, now what do I have? I have this exponent alone on the left side. Now I can go to work. Now I can use our circle. I can say that the log base 3 being raised to the x power means that the argument will be 5/8. Okay, so log base 3 of 5/8 is equal to x. And again, I kind of used a circle. It kind of works the same way, right? Log base 3 of 5/8 equals x. All right. Now, the small little piece that we're going to introduce here to get us, or to start us getting ready for graphing these next week, is a couple of things. I mean, we can get some nice points very easily with logarithms. Just like we had nice points with exponentials, we have nice points with logarithms. All right, and here's our hint right here. All right, evaluate the logarithm for the following values: x equals 1, x equals 8. So let's do it. Log 8, base 8 of 1. Ooh, what's true here? Log base 8 of 1? Hopefully you guys are recognizing that this is a rule. The other way to think about it is logarithm means I'm trying to find what exponent I need to raise this base to get 1. Well, how do I get anything to 1? The exponent has to be 0. Okay, so now I plugged in 1 for x, I found y was 0, which means I have a point. And oh my gosh, the y value is 0. What does that mean this point actually is? I hope you said x-intercept. Okay, we have the x-intercept. We have the x-intercept because y is equal to 0, and we know that any x-intercepts will occur when y is equal to 0. All right, so that is a huge piece right here. We know that if the argument is 1, the y value will have to be 0. All right, now let's find another nice point. Y equals log base 8 of 8. Okay, this is another rule. Or remember, I want to get this base 8, raise it to some power to get 8. Well, what power do I have to raise it to? You guessed it, 1. So now I have an x value of 8 and a y value of 1. And I would now have two really, really, really nice points to graph, or plot, I should say, on my logarithmic function. Okay? So, let's take a look at the next ones to practice a little more. I want to find the x-intercept and another nice point. Well, we knew what? The x-intercept only comes from when y is equal to 0, right? So I need y to equal 0. And what is this saying? If my logarithm is equal to 0, that means that this is my exponent for my base. So 7 to the 0th power is 1. So if y is 0, x has to be 1. So my x-intercept then I can finish up by saying 1, 0. All right? Now I do need another nice point, and if you remember from the problem ahead, or before I should say, we have a little trick. We're going to say that we want our argument to be the exact same as the base. So if my base is 7, then I want my argument to be 7 as well. So y equals log base 7 of 7, and we know this. You can either use the example before or your rules. We know that y has to equal 1 there. Okay? So I now have my other nice point, 7, 1. All right, does that make sense? I hope so. Next one, we want the x-intercept. So again, we need y to equal 0. We have ln of x. Well, we know that the base is e, but raise anything to the 0th power, and what do we get? We get 1. Okay, so x is going to equal 1. We have our point 1, 0. Interesting. Seems to be something occurring multiple times. All right, on that last nice point, remember, the easiest way to get another point is to have the argument be the same as the base, and if my base is e, then I need my argument to be e. E to the what power is equal to e? You said it. Y equals 1. So we have another point at e, 1. All right, last one. We want the x-intercept first, so that means we need y to equal 0. And we know 1/4 to the power of 0 is 1. So x equals 1, which means, once again, I have a nice point at 1, 0. All right, please notice that. All right, and lastly, remember, we like to have our last nice point be when the base and the argument are the same. Because now I ask you, what power do I need to raise 1/4 to get to 1/4? And the answer, of course, is 1, which means I have my last nice point at 1/4, 1. All right, so that is where I'm going to stop. The expectation for the rest of your evening, or whenever you are completing this, is to work on these true-false problems. All right, these shouldn't take too long, but I will let you know, Ms. Braytek and I talked, and these were definitely some common errors that she saw last year. Okay, so I want you guys to think really hard about these, try to come up with a good answer. We'll check those and talk about them. And then I also want you to try these last 4 problems on page 26. All right, we will go over these in class tomorrow. Have a great day. See you next time.